The Jensen measure is one that drives off the capital asset pricing model. You calculate this equation here, the return on the portfolio minus the expected return on the portfolio if the capital asset pricing model holds, given the unique beta of the portfolio. And what's in square brackets here is the CAPM equation, risk-free rate plus beta times the risk premium, using the beta of the portfolio. Of course, any factor model could be used, but in the case of Jensen, he's using capital asset pricing model. This is a measure of value added, a measure of alpha. It tells you the excess return over the expected excess return per this model. And you could even decompose it into various periods if the risk-free rate changes, because as you can see, the risk-free rate is an important element of this equation, and if that's changing with different periods, you might decompose this Jensen calculation into those various periods. So what Jensen is trying to get at is, to what extent was there value added over the expected amount? And finally, the information ratio, which has become quite common in the industry as a measure of skill. The information ratio it's again a ratio. The numerator has the excess rate of return over a benchmark, and the denominator is the volatility of that excess. So what you would do is you would line up the returns of the manager on perhaps a quarterly basis. You could do it on a monthly basis. You would line up the returns of the benchmark. You would take the differences, and you would work out the average difference, the average excess, put that as your numerator, and work out the volatility of those excesses, and that would be the denominator, to give you the information ratio calculation. If you were using quarterly data, you would annualize it by multiplying by the square root of the number of periods, in that case the square root of 4. In terms of the measure and how it looks, a score of between 0.5 and 1 is felt to be a good score. And this has become quite common in the industry as a measure of skill, in that obviously skillful managers give you an excess return on the top with low variability. In other words, the volatility of their excess is low. That's going to give you a large information ratio measure. High numerator, small denominator, large information ratio. But it is really more relevant with managers that are managing to a benchmark. If you have a manager that's building a more concentrated portfolio, much more focused, they'll have more variability of value added. So, for example, concentrated value portfolios are going to be more different to the benchmark. Big bets versus the benchmark. They're going to give you more volatility. They might do very well over the benchmark over the long term, but with so much volatility that even though you get paid over the long term, the information ratio score isn't as strong. Whereas an enhanced index manager taking small bets may have such a stable alpha, they get a huge information ratio score. So you've got to be careful about how you interpret the measure. Now in the next section, we need to get into performance attribution in more detail. There are really two sources of value added at a high level. One is the asset mix decision, overweighting equities, for example, relative to your policy benchmark. So if your policy benchmark is 60-40, 60 equities, 40 bonds, and you're at 65, what was the value added from that decision? And the other would be within equities. Did you add value by buying the right securities? And that would be more of a security selection, alpha. Starting with asset allocation or the tactical decision to perhaps go overweight equities. In respect of each asset class, and you would do this asset class by asset class, you would look at the actual weight. Let's say, for example, you were at 65 equities minus your policy weight of 60, difference of 5%. You would multiply by the equity return in the policy portfolio, so the benchmark return of equities, minus the total return in the policy portfolio, so the passive return in the 60-40 portfolio. And that's the formula from equity alpha. The decision to overweight multiplied by the impact of those equities in the policy portfolio of 60-40 on a passive basis rather than an active basis. Because clearly we're not interested in any source of alpha from active security selection at this point. Now moving on to the security selection source of alpha. Now here we're not interested in whether or not you're overweighted or underweighted relative to the 60-40. So you take the actual weight, which is 65% in our example, and you multiply by the return on equities or whatever asset class you're calculating in your portfolio, in the actual portfolio, or the manager's portfolio, the client's portfolio. You difference that off of the return, again on those equities in the policy portfolio. So this tells you the security selection alpha, manager's return on equities minus benchmark return on equities. multiplied by the actual weight in the portfolio. When you sum everything up, just check and make sure that everything adds up to total alpha. If not, obviously there's something wrong. One thing to bear in mind is this analysis of return or of alpha ignores risk. So you've got to ask yourself the question, if there's a value added, is it because of manager skill or simply the fact that the manager has exposed you to more risk and gotten paid for that extra risk? Now there is some criticism from Roll regarding some of this theory. His criticism in particular applies to Jensen's alpha and the information ratio calculation, because in these two you're using either beta measures or benchmark measures. And it's this notion of there being a market portfolio and there's an appropriate beta calculation which drives off the capital asset pricing model. His criticism would be, well, what if the benchmark you're using isn't really a market portfolio? Again, going back to the notion that the market portfolio represents a portfolio of all the available assets, fully diversified. Well, if the S&P 500 isn't the appropriate market portfolio, do you get an appropriate beta? And if you don't, then wouldn't that change the slope of the security market line? If that's the case, would it maybe change the rankings of your managers? Because you're ranking managers depending on some of these scores, interpretation of beta, interpretation of alpha over benchmark. And if the beta is subject to some flaw, or the benchmark is, that might change the calculation if you were to recalculate it using a different benchmark or a different beta, and it might need you to have a different interpretation of how managers are ranked. In this context then of benchmark error, the way that you would address this is, well, firstly you would try to use as broad benchmarks as you could. So instead of the S&P 5, you might use Russell 1000, you might use Russell 3000. Or, use some of the other measures as well. Complement what you're doing by using other measures like Sharpe ratio, which aren't as reliant on benchmarks. Now, in the next section, we're required to look at the bond market line, and the way this line looks is as follows. Again, return and risk is really the driver of the two axes. Return, again, on the y-axis. But risk for a bond portfolio isn't beta, it's duration. That's really been found to be the key determinant of risk, is whether or not the manager is overweight or underweight duration. So while the line looks familiar to you, and T-bill is, again, the intersection, bear in mind that whereas on the security market line, beta is on the x-axis, and the bond market line, it's duration. And the bond index, which in theory should fall on the line, is obviously a bond benchmark. So, for example, you'd be looking at either a Lehman Brothers aggregate type index or a Salomon Brothers index for the bond market line. Getting into more detail then on bond attribution, what we're trying to calculate now is the return on the actual portfolio less the return on the bond index. And we can use the concept A minus B is equal to A minus X plus X minus B. And then break down that equation into these two to understand attribution in more detail. That's the concept we're following. That equation up there is equivalent to this one down here. The return on the actual portfolio minus the return, and this is our X, on the long-term strategic portfolio, which follows the manager's long-term strategic duration, which I'm going to call DS. Add that one back in, and then subtract the final item up there. This equation over here is identical to that equation up there that I'm trying to understand. The first one, which is the return on the actual portfolio minus the return on the long-term strategic portfolio, tells us the alpha that the manager drove by managing it in a certain way, even different to his long-term strategy with duration DS. The second one gives us the alpha of his long-term strategic portfolio using DS, minus the return on the index, which has a different duration DI. And that's known as the policy effect. The effect of the manager having a long-term policy with a different duration to the duration of the index. That second one is fairly straightforward.